So this is another straightforward question. So question number 10, a solution is prepared by mixing 250 cubic centimeter of sodium sulfate. The concentration is given, and 700 cubic centimeter of NaCl solution. Again, the concentration is given. So finally, they are asking about ppm of sodium. Okay. Try to first understand what is ppm. Okay. ppm means parts per million. So if we have million number of atoms, how many atoms are sodium in the solution? Here, if you think in this solution, you have sodium atoms, Na plus atoms basically, Na plus ions, sulfate, H plus, OH minus, because these are aqueous solution. So out of these, if you have million, how many Na plus will be there in the solution? That is what parts per million means. Okay. In your level, parts per million, in general, we say that is the milligrams of the compound per a decimeter. Okay. But remember, the definition of ppm is not milligrams per decimeter. Try to understand the difference. ppm in general, the definition is parts per million. Okay. It can be parts per million in mass, part per million in this milligrams per decimeter, just parts per million in amount. Okay. But at your level, when we express your concentration of a certain species in milligrams per decimeter, it gives the idea of ppm. So first thing, you should remember what is ppm with respect to concentration. It is milligrams per decimeter. Second thing is how to find Na plus in the solution in milligrams per decimeter. The only thing that you should know here is when you add sodium sulfate, Na plus is given by sodium sulfate as well as Na plus is given by NaCl as well. Okay, so I am going to write down the equation like this. Na2SO4 will give 2 Na plus and SO4 2 minus. 1 mole of this will give 2 moles of this. So you can calculate the number of moles using this, and its number of mole will be twice because stoichiometry is 1:2. Then you can use this volume and concentration to find the number of moles, that is this. In the same way, you can do for NaCl, how many Na plus moles. So the total number of moles at the end in the solution will be sum of this and this. So it will be like this, 0.15 mole. Okay. And you know, the concentration is now 0.15 mole. The volume is 1 decimeter. Why? Because you mix 250 cubic centimeter with 750 cubic centimeter. The total volume is 1000 cubic centimeter, which is 1 decimeter. So now you have 0.15 mol dm minus 3 concentration in mol dm minus 3. But you need it in milligrams per decimeter. This one. So how do you convert these moles into milligrams? First thing, you can multiply it by the molecular weight of sodium, because here you are considering only the ppm of sodium, not other species. So you have to multiply the concentration by the molecular weight of sodium. So the molecular weight is 23 gram per mole. But you need it in milligram. That is why I have to multiply this by 10 to the power 3 factor to convert gram into milligram. So at the end of this result, you will have a ppm of 3450. Okay, so try to understand that concept. Okay, and you can try to find the ppm level of sulfate. Can you find the ppm level of sulfate in this solution? The only thing is the number of moles will be equal to sodium sulfate, but the volume will be changed to 1 decimeter. Okay, because 250 centimeter, 750 centimeter, you are mixing. The only thing that will happen is sulfate that is given by Na2SO4 will be diluting up to 1 decimeter. The concentration will be little lower. That's all. Then you can multiply the concentration by the molecular weight of sulfate to get the ppm level. That's all. Okay. I hope this is clear.